Okay, my dear students, uh, am I audible to you now?
Yes, sir.
Shall I start my class?
Yes, sir.
Shall I start now?
Yes, sir.
Okay, sir. Okay, thank you. Now comes this, there is a third example. It is an infinite solution. Previous problem is unbounded solution, previous problem. And the first problem is a straight simplex problem. Now this is, in the first problem, you got the solution for the maximization problem. Whereas in the second problem, you did not get, because all the, this is the entering column, all the elements are with a negative sign. When you capture the ratio is getting as negative, hence it is an unbounded solution, we can call it as. So you cannot conclude a critical element at any point on this particular thing because of the negative ratios. Negative ratios or infinite ratios, whatever it may be, they cannot be considered. So hence thereby you cannot identify the key element. When you fail to identify the key element, automatically the solution is unbounded. So it is going to be called unbounded. You cannot find a solution for the particular problem. Now this is an infinite solution. The maximize z is equal to 4x1 plus 10x2 subject to the constraints 2x1 plus x2 less than or equal to 10, 2x1 plus 5x2 less than or equal to 20, and 2x1 plus 3x2 less than or equal to 18, where x1 and x2 are greater than or equal to 0. So this is a simple problem through which you can understand easily. It is there are two variables, x1 and x2, and this is a less than sign, and this is also less than sign, and the third one is also a less than sign, and automatically, so the problem attracts only slack variables, that is plus s1 for this, plus s2 for this, and plus s3 for this, s1, s2, s3, like that. You will attract three slack variables, and thereby you have to convert the problem. So introducing non-negative slack variables to convert inequality constraint. Inequality constraint means less than or equal to constraint to equality. Then the LP problem becomes maximization z is equal to 4x1 plus 10x2 plus 0s1 plus 0s2 plus 0s3. So there are three equations. That's why S1, S2, S3. Three constraints and three slack variables. Three constraints, three slack variables, and we have added. So therefore, the initial objective function becomes maximization z is equal to 4x1 plus 10x2 plus 0s1 plus 0s2 plus 0s3. The objective function shape should not be altered. Hence, 0s1, 0s2, 0s3. Next, subject to the constraint 2x1 plus x2 plus s1 is equal to 10, 2x1 plus 5x2 plus s2 is equal to 20, and plus s3 is equal to 18, where x1, x2, s3, and s3 should be greater than 0. Now you constitute the table. Cj is equal to, so Cj means this is 4, 10, and 4, 10 means x1, x2, s1, s2, s3, and 4, 10 remaining all the quotients are nothing but the multiplication factors are nothing but 0. And here all these are zeros, variables are s1 and s2 zeros. The solutions 10, 20, 18, 10, 20, 18 like this. Next, 2x1 plus x2, 2x1 plus x2 plus s1 means 1 is equal to 10. 2x1 plus 5x2, this is 2x1 plus 5x2 plus s2 is equal to 20, and 2x1 plus 3x2 plus s3, 2x1 plus 3x2 and s3 is equal to 18. Like this we have formulated the particular. Now you have to identify the zj value. So 0 into 2, 0 into 2, 0 into 2. Similarly 0 into 1, 0 into 5, 0 into 3. So like that, because of all these are zeros, you will get zj values as zeros. So therefore, this is Cj minus zj, 4 minus 0, 10 minus 0, 0 minus 0, 0 minus 0, 0 minus 0. Finally, automatically you are going to get the CJ minus ZJ is nothing but 4, 10, 0, 0. Now, it is a maximization function. The objective function is a maximization function, and you have to identify the maximum positive value. Maximum positive value. So 4, 10, 0, 0s are there. So in this, you will get a 4, 10, 0, 0s, all those things, and among them, 10 is the maximum positive value. So therefore, this becomes the entering column. Therefore, this becomes the entering column. In the entering column, 1, 5, 3 are the elements. 1, 5, 3 are the elements under X2, 1, 5, 3. So therefore, 10 divided by 1, you will get a 10. Ratios you have to identify. So 10 divided by 1, it is 10. 20 divided by 2, 20 divided by 5, it is nothing but 4. And 18 divided by 3, it is nothing but 6. So 10, 4, 6. Among all the things, what is the least ratio? 4 is the least ratio. Least ratio. Therefore, you mark a horizontal arrow here. Mark a horizontal arrow. Therefore, the 5 becomes the key element. 5 becomes the key element, and this becomes the entering column, and this is the entering row. We can call it as entering row, and at this particular junction, 5 is the key element. 5 is the key element. So like that, this particular 5 has to be turned into 1, whereas 1 is turned into 0, and 3 must be turned into 0. So 1 and 3 must be changed to zeros, 5 must be changed to 1. So if you intend to change this into 1, divide the entire row. Divide the entire row by 5. So before that, you identify, now this is the x2 and 10. X2 and 10 are there. X2 and 10 are there. And this x2 will replace s2, and this x2 quotient, nothing but the multiplication factor, 10 is there. 10 will come and occupy. 10, and this S2 will go out, 0 will go out, and instead of S2, you will get X2 here. This X2 will come and occupy this. And 10 will come and occupy this particular position. So 10x2, whereas the remaining thing 0s1 and 0s3, they remains the same. Okay, after 10x2 is over. Now this is the 5, 20 divided by 5. This is 20. You have to make it 1. Hence, the 20 divided by 5, it is nothing but 4. And 2 divided by 5, you got it? 2 divided by 5. And 5 divided by 1, it is 1. And 0 divided by 5, 0. 1 divided by 5, it is 1 by 5. 0 divided by 5, 0. So this is the new row 2, what we are going to call it as new row 2. So you have to mark it as row 2 here. So after this row 2, with respect to this row 2, you have to develop this new R1, and you have to develop this new R3. So new R1 and new R3 you have to develop. So therefore here you can find out this new R1. New R1 is equal to old R1 minus 1 into this new R2. Minus 1 into this new R2. So here it is new R1 is equal to old R1. Old R1 means this is old R1. Old R1 minus this is old R1 minus this is nothing but the new old R1 minus this is new R2. New R2 is equal to old new old R1. sorry, new R1 is equal to, I'm confusing. New R1 is equal to old R1. Old R1 is 1 here. ఇక్కడ 1 ఉంది కాబట్టి 0 చేయాలి. Old R1 minus new R2. Old R1 minus new R2. If you write down, automatically it will get 0, and remaining as per that particular equation. If you do every element with that particular thing, you will get the other elements like this. Next, similarly, this is new R3. This is new R3. New R3 means with respect to old R3. This is old R3 in the first iteration. Old R3 minus 3 into new R2. Minus 0 అవ్వాలి కాబట్టి minus 3 into new R3. Minus 3 into plus 3. Minus 3 minus 3 plus 3. Automatically it will become 0 here. So here you have to write down new R3 is equal to old R3. Old R3 means this is old R3 minus 3 into new R2. 3 into new R2, then you will get this particular 0. So if you apply this, my particular equation, that is new R3 is equal to old R3 minus 3 into new R2. This is new R2. This is the equation. One dento vachindho danto cheyali. So like that, you will get the elements like this: 6, 4, 6, 8 by 5. All these things are there. Next, after that, you have to identify Zj. Zj you have to identify, and here it is 0 is there, 10 is there, 0. Previously all zeros means you got all the zeros. Here there is 10 is there. 0 into 8 by 5, 0 plus 10 into 2 by 5. 10 into 2 by 5, 20 by 5. Automatically it becomes 10 by 2 by 5. So 10 by 2 by 5, it becomes, ratio is coming as 10, and 10 into 2 by 5. It is coming as 4. Sorry, 0 into 8 by 5, 0, 10 into 2 by 5, and it coming as 4. Next, 0 into 1, 0 into 0, 10 into 1, 10 into 1, 0 into 0. So here you will get 10. Next, 0 into 1, 0, 10 into 0, 0, and 0 into 0, finally you will get 0. Next, 0 into minus 1 by 5, 0, 10 into 1 by 5. 10 into 1 by 5 means you are getting 2. And 10 into 0 means automatically you are getting 0. So like this, Zj you are getting. So all these values are to be multiplied in these particular values, and you have to add them. Again, all these values, they are to second row. So with this particular column, you have to third column, fourth column, like that, multiply and develop the Zj. Now Cj minus Zj you have to find out, and so there is a 4 and 10 are there. 4 and 10 are there, and you got this particular thing Zj as 4 and 10. 4 minus 4 you are going to get 0. 10 minus 10 you are going to get 0, and similarly 0 minus 2 you are going to get minus 2, and this is nothing but the 0. So these are the 0 values, either zeros or negative values, but you are not getting so any positive values. So this is Cj minus Zj. It is a minus 2 value, and automatically this x2, and we can end up the particular solution with this particular thing. X2 is equal to 4 because it is a maximization problem. When maximization problem is to be ended, all Cj minus Zj should be either 0 or negative. So Cj minus Zj, there are 3 zeros, 1 negative, zeros. So therefore here this is x2 is equal to nothing but the 4. X2 is equal to 4. Whereas x1 is not there and x3 is not there. automatically they are zeros. X1 and X1 is there only X1 and X2 are the variables. Automatically X1 is 0, X2 is equal to 4, and that you have to calculate. So that means you substitute X1 is already 0, X2 you put it, automatically you will get 40 as the value. So this is the way you can stop at this particular point, but still there is something else he's doing, and all those things are not required. And even then, again, CGMN is at all the negative values. So there is no point in continuing. This is X1 and X2. He's saying that you need not go for the next iteration. So here, for an unbounded solution, this -2 has to be changed into positive value, sorry, 0 value. For that particular purpose, he has carried out. And in this particular fashion, this is he has taken this first column and convert this as into the next problem. So this is 8 by 5, 2 by 5, and 4 by 5. So this is a unit matrix, and again you have seen that it has come as unit matrix. For that particular purpose, he has gone for the ratios. Gone for the ratios means, so this particular x1, he has marked like this, x1 is equal to 4. And to make this particular 8 by 5 into 1, you multiplied by 5 by 8. So 5 by 8 into this 6, you got like this. 5 by 8, all these things he has carried out. Next, similarly, this 2 by 5, he made 0. 4 by 5, he made 0. With respect to this, rho 2 is equal to old R2 minus 1 into new R1. And similarly, rho 3 is equal to, and rho 3 is equal to, as also old rho 3 minus new rho 3 is equal to old rho 3 minus 5 by 4 into this new rho 1. Like this he has carried out. So 1 0 0 0 1 0, and these are the values, and that is all these things. That is nothing but the top values. 4 into 1, you are getting 4 here. 10 into 1, you are getting 10 here. So 4 into 5 by 8, 10 into minus 1 by 4, 0 into this thing, you will get, finally you are getting zeros. And again 4 into minus 1 by 8, 10 into 1 by 4, and 0 into this thing, you are getting all these 0 values. So here, all CGMN is either 0 or negative. It gives an optimal feasible solution. So the actual optimal feasible solution is, this is the particular thing. But one of the non-basic variables, x1 is 0. X1 is 0. It indicates the existence of alternative optimal basic feasible solution. So this is an optimal alternative solution. So in the examination, if you are asked to find out, this solution is more than sufficient. This solution is more than sufficient, and you need not go for this particular thing. But a further alternative solution here, if two basic feasible optimal solutions are known, an infinite number of non-basic feasible optimal solution can be derived by taking any weighted average of these solutions. So after this, you can find out x1 is equal to 15 by 4 and x2 is equal to 5 by 2. x1 is equal to 15 by 4, it is coming. Previously, it is x2 is equal to 4 only ikkada, and whereas x1 is equal to 0, and that is equal to, you got like this. Whereas now in this particular problem, after iteration of this, x1 is equal to 15 by 4 and x2 is equal to 5 by 2. If you substitute these values in the initial optimization equation, 4x1 plus 10x2, you have to identify what is the z value. So here you are getting one more z value, and this is the initial z value, and like this, two alternative solutions. So yes, already given here, x1 is equal to 0 variables, First variable, second variable, 0, 4, and 15 by 4. So general solution, he has mentioned it. So you need not bother about all these things. You can avoid this particular step, and you can stop these. Two alternative solutions are there. So like that, two alternative solutions in the name, you can avoid the further confusion or clarification, whatever it may be. Next, so far we have dealt three maximization problems. So far we have dealt three maximization problem. Example 3, and this is example 2, and this is example 1. Example 1, simplex method. All these are nothing but the maximization problems. Okay. Next, after this, so this is a minimization case. Minimization case. So in certain situation, it is difficult to obtain an initial basic feasible solution. So A, first case, when the constraints are of the form less than or equal to, so less than, then x greater than, but some right hand right hand side constraints are negative, then in that case, after adding the non-negative slack variables S1, the initial solution so obtained will be Si is equal to Bi. It violates the non-negative condition of the slack variables. Next, when the constraints are in the form of greater than or equal to when the constraints are in the form of greater than or equal to, it is less than or equal to, greater than or equal to, he has given certain conditions how to deal. So this is to solve the when the constraints are greater than, example Aj xj greater than Bj xj greater than or equal to 0. In this case, to convert the inequalities into equation. So I told you that inequalities less than or equal to, greater than or equal to, they must be converted into convenient form. If it is less than or equal to, it becomes a maximization problem. It is a greater than or equal to problem, and automatically it will become a minimization problem. So that is the difference in this particular case. To solve the type of problems, we are adding artificial variable. So this is artificial variable, surplus variable, slack variable, surplus variable, artificial variable. So artificial variable, we are artificially adding certain variable, hence it is going to be called an artificial variable to balance the equation. That the new solution to the given LP problem does not constitute a solution to the original system of equations, because the two system of equations are not equivalent. Thus, to get back to the original problem, artificial variable must be driven to 0 in the optimal solution. So there are two methods to eliminate these variables. One is two-phase method, and second one is big M method or penalties method. Big M method or penalties method, two-phase method. So now this is the big M method or the method of penalties, what we can call it as. Generally in the examination, you will be given the minimization problem. You will be asked to solve the problem LPP, linear programming problem, by big M method. Or sometimes to confuse you, he will ask you solve the minimization problem or solve the given problem by method of penalties or penalty method. Simply he will call it as penalty method. In this method, the artificial variables are assigned a large penalty -m for maximum and +m for minimum problems in the objective function. -m for maximum, +m for minimum problems in the objective function. You can understand at a later stage when you are solving the problem, big M or small m, whatever it may be. So this is a big M. Always you have to assume that a larger value for the M, and thereby you have to decide the quality of the particular equation. Now he has given maximum z is equal to 3x1 minus x2 subject to 2x1 plus x2 greater than or equal to 2, x1 plus 3x2 less than or equal to 3. He has given just, and x2 is less than or equal to 4. There are three constraints. And x1, x2 greater than or equal to 0. So he has given introducing slack variables, surplus variables, artificial variables to convert inequality into equality, then the LP problem becomes. Slack variables ante less than, when there is a less than sign exists, when less than sign exists, you are going to add the slack variable. When there is a greater than sign exists, automatically surplus variable along with artificial variable are to be added. It is again greater than or equal to 2, surplus variable and artificial variable both are to be added. That is very important. Again, less than means again plus S2 is going to be added. Is less than 3 means plus S1 can be added. So like this, things are to be solved. Here, after introducing slack variables, surplus variables, artificial variables to convert this particular problem, maximization z is equal to 3x1 minus x2. 3x1 minus x2 plus 0s1 plus 0s2 plus 0s3 plus 0a1. So this is s1, s2, s3. S1, S2, S3, but greater than is there. For this, you have to add artificial variable. Artificial variable. So because this is less, you are going to add plus S1, or this is going to add plus S3. So because this is the first equation, we are going to add S1, S2, S3 like this. So therefore 0S1, 0S2, 0S3 plus A1. Okay, subject to the constraints 2x1 plus x2. The first equation shown here, 2x1 plus x2, okay, minus s1, because greater than is there, minus s1 plus a1. So y minus, because it is going to be called as a negative variable, then we are going to call it as a surplus variable. If it is a plus 1 plus s2, we are going to call it as a slack variable. Whereas a1 is equal to artificial variable. Whenever there is a greater than or equal to sign exists, you have to add minus s1 plus a1 is equal to 2. So therefore, I hope that you have understood this first equation. Second equation, x1 plus 3x2 plus s2 is equal to 3. Next, x2 plus s3 is equal to 4. So like this, you got this particular thing. And here you can say that x1, x2, x3, s1, s2, s3, and a1 all should be greater than or equal to 0. So therefore, you can find out here, you draw the particular table. You draw the particular table, and this now you got this particular artificial variable, and this is a little bit confusing. So this is CB values. So previously it is S1, S1, S2, S3. Now this is artificial variable 1 who is there, 1, 0, 0, A1, S2, S3. S1 does not come here. And here X1, X2, S1, S2, S3, A1. S1, S2, S3, A1. So all these variables are to be clearly marked out the entire table. Now A1, S2, S3. S1 does not come, and only A1 will play a major role. And the equations are 2, 3, 4. 2, 3, 4. The end of the equations, 2, 3, 4 are to be marked here. After this is the first equation, 2x1 plus x2. 2x1 plus x2 minus s1. Minus s1 plus a1 is equal to 2. I have marked. So this is 2x1 plus x2. 2 and 1 we have marked. So this is minus s1. So hence minus 1 here. And plus a1, 1 here. And this is automatically 2 means this. Next, x1 plus 3x2. So this is x1 key multiplication of 1, and 3x2 means 3, and s2 is equal to 1 is equal to and S3 0 and A1 0 automatically. Artificial variables are not there. And third equation, this is just x2. x1 is not there. Hence, instead of x1, we mark it as 0. This is 1. And 0, 0, S3. And like this, these are 4 values. And we are calculating. Now, I told you Cj minus, so Zj value you have to find out. Zj value. So, for artificial variables, so you got this particular thing. You see that 3 here minus 1, 0, 0 and minus m. So artificial variable, whenever you find a artificial variable, you must indicate this particular minus m. So that is because it is a big M method. Whenever is the particular thing, a maximum value for the artificial variable, a maximum value for the artificial variable. Now comes to this, you multiply 1 into 2, 2, here not 1, this is minus m. This is minus m.